much for having me. The travel was quite easy these days, so thanks for having me at your meetup. The unofficial title of this talk is Testing Your Tests Without Writing Tests for Your Tests, which is, to be honest, a pretty damn good explanation of what you will or have to expect for this session. Sadly, for a conference talk, I really needed to shorten the title, so the unofficial version is how good are my tests? And that's actually a pretty damn good question you could ask your coworkers when you're at work tomorrow, just to see like the general perception of your code base. Feel free to ping me afterwards and tell me what the responses were. So who I am, hi, I'm Stephan. Don't even try to pronounce my last name. That's totally fine if you just call me Stephan. I do speak at meetups and conferences a lot. So usually I speak in venues like Las Vegas, the Broadway, big German football stadiums, theme parks, whatever. But I do really like to speak at meetups. Sadly, as a speaker in the PHP world, I can't make my living out of this, so I have to run a little side hustle, and that's the company I founded about 18 years ago, BitExpert. We are a web and mobile development company in a couple of countries, doing all sorts of applications for our clients. And since I've still got some spare time left, and I'm not exactly sure how that happened, I am not only organizing one, but actually two PHP meetups. One's called the PHP user group in Frankfurt, and the other one is called the PHP meetup Metropolregion Rhein-Neckar. So that's a very German name, I know that. Great, but that's mostly it about myself. So before we start wondering how good are my tests, we probably should step back and ask ourselves, how good is my code, right? Because like that's the essential thing. And that's up a bit for participation right now. So imagine from a scale from 1 to 10, where 1 means my coworker wrote my piece of code, and 10 means basically I'm a cranius. How good do you think your code is? Just use the chat and -3. Okay, I don't know what to say. Okay, let's see where this is going. So to answer the question, how good is your code? Things like code quality comes to mind. And there are a couple of tools out there that can help you answer the question. There's Scrutinizer, which you can see in the screenshot. There is like Code Climate, SonarQube, and dozens of other tools that somehow magically come up with some weird random number, like in this case 9.46. That sounds quite decent, right? I mean, given the top end of the scale is 10, that's quite decent. They also tell you that it's very good code, but I mean, what does that really mean? If you Google a bit for code quality and how to identify code quality, you'll quickly come around and find that there is an ISO standard for software quality, and code quality is part of that. And to be honest, whenever you hear it's an ISO standard, you probably should run as fast as you can. If you don't, you'll get trapped. And code quality or the software quality standard defines a couple of criteria to identify code quality. Things like functionality, reliability, usability, efficiency, maintainability, portability. But what does that really mean? Like, I mean, is my code functional? Yeah, maybe. Is my code reliable? I hope so. Is my application usable? Well, I guess. Is it efficient? Probably. Like, there's no real metric that can really tell you what is good and what is bad. And this is obviously due to the fact that software development is a creative process. So there's no good or bad. It's just like different perceptions. So we have to search along. Since Google didn't work for us, we'll use Bing and just search for criteria for good code. And we'll come across a couple of blog posts, and they all more or less boil down to three things. First of all, how good can I follow along? Like, how readable is the code? What does the author want to tell me? Is it possible to test the code in any way, unit testing or integration testing or whatever? So any kind of automated testing. And last not least, how easy is it to extend and modify the code without breaking things, obviously. So, okay, that might help us to get started. So we start our first development project. We'll try to keep up a high standard, and obviously we also write tests. Yeah, little motivational, yeah. And that then obviously leads to the question, like, how good are my tests then? And since there is a metric like code quality, is there anything comparable to testing and how good tests are? And when I ask this question at conferences and meetups, the usual response is something like code coverage, because that's what people know. And this is basically the code coverage for this project that I've shown you before. That was in Scrutinizer. So we got a line coverage of 99.84 and the class and traits coverage of 96.97%. So that's quite high. So you could say that's a pretty decent quality project, and probably or potentially tests are also good. But the question is that really the case? Is code coverage really a good metric to identify the quality of your tests? And if I ask this question in that way, the obvious answer is no, and let me prove it to you. So this is one of the many tests in this project. What we do here is we create an instance of this parameter class, we pass an array configuration to it, and simply check if the getDefaultValue method will return null if we haven't defined it. Perfect. Now, let's say I make some changes to the code base, I make some changes to the tests, and by some weird means, I accidentally delete the assertion. Now, I still have 100% code coverage, but I'm lacking the assertion. So basically, the test is not functional. It doesn't test anything. So if getDefaultValue after my changes would return 0 or 1 or whatever, it wouldn't be detected and it wouldn't fail. So this clearly shows you that code coverage isn't the best metric to express the quality of your tests. So that then leads us to the next question, like what is a good unit test? What's the criteria for that? Again, Googling a bit, you'll come across an acronym that is called FIRST. The F stands for fast, so unit tests need to be executed fast to not annoy us in our daily work. They should be able to run isolated, so they don't have any side effects at all. They should be repeatable and deliver the exact same results, the same outcome on each and every test run. They should be self-validating. So if I try to read the test code, I should understand what the test is doing and understand if everything is right. And I should write these tests in a timely manner, meaning like instantly when I wrote the code or before I wrote the code, depending if you do TDD or not, and not like 6 months later or maybe a year later. That doesn't make sense, because if there's a bigger gap or time-wise gap in between, you don't know or you don't remember like all the implicit assumptions that you probably did, and you can't really cover the code and its execution correctly. Which basically is one thing that is missing for me in this overview. The question really is like, how good do these tests cover the implicit assumptions that I've taken when I've written the code? And that's definitely a big showstopper, and something you need to consider to figure out like if your tests are good or not. Okay, so what does that mean? Well, quite easy or quite simple. We basically need tests for our tests, right? We need to make sure that our tests work correctly. Great, and if we have tests for our tests, we obviously need tests to test the test of our tests. And since we have tests for the test of our test, we do need write tests for the test. You get the point. So that's not feasible. That doesn't work either. And also the question in this case is like how would these tests that test the tests look like, right? So coming back to the previous example, what would I do to test this test to make sure it's correct? Well, I would need a way to check if there is a parameter object instantiated, if the parameters are passed in the correct order. I would need to check if an assertion was called, like the null assertion in this case. I would need to check if the get default value method is called. So more or less, I have to use the same information that is already in this test to validate the test, which then again does not make sense. So we need something else for that. Why not do the obvious and why not change the code to test our tests? I mean, not change, but like, why not break our code to test our tests? Because obviously if we change the code and break it and specifically, our test should fail. And if it has fails, we figured out like the tests are working. And that's, in a nutshell, the general idea behind behind the mutation testing idea. So that's something that came up as almost all the good stuff in software development in the last century, in the 1970s, but it never lifted off due to a few constraints or restrictions that we'll cover later. The general idea behind mutation-based testing are two theorems. One is called the competent programmer hypothesis. And I know that each of you is currently thinking of a coworker who is definitely not competent. Just move that thought away for a moment. The general idea behind this is that if, let's say, a customer is coming to us and wants us to develop a, let's say, an inventory management software, we don't come back to him with a marketing tool or any kind of CRM tool or whatever. So we do get quite close to what the customer wants, but we may miss a few details here and there. So that's basically the general idea behind that. And the second component of this is called the coupling effect. And the idea in this case is that simple errors have complex errors as a result. So if I take a method, for example, I don't need to understand what the method is doing to make a change, to make the method fail in whatever way. It is absolutely okay to just make a small minor change somewhere in the code that will lead to an error, to just prove that the whole method is not doing its job. That means in turn that the mutation-based testing framework does not need to understand my code to make modifications to test if the code or if my tests are working or not. It's totally fine to just like make small minor changes. And these small minor changes are called mutants. These mutants are created by something that most of the mutation-based frameworks, testing frameworks, call mutators. Based on the framework that you're using, there are a lot of different mutators around. Ones that, for example, change the function signatures, changing public functions to protected functions, changing protected functions to private functions, doing Boolean substitutions, doing or changing the way increments work, changing return values, changing looping and sorting, having fun with typecastings, and so on and so forth. So let's have a look at Boolean substitution as a quick overview. So the idea is that the mutation-based testing framework will have a look at your source code. It will analyze it. It will figure out, hey, there is somewhere in the code there is a keyword called true. So it will copy the class or the file where this true keyword appears and change that to false, and then run the test and see what's going on. And the same the other way around. So if it finds false, it will replace it with true. If it finds a logical AND, it will replace it with a logical OR, and vice versa. And same for the logical lower AND and logical lower OR. And for the logical NOT, it will replace it with a not. I don't know how you call that. It doesn't matter. And just then again, run your tests and see what's going on. Quick example to probably better understand what I'm trying to say. So this is the constructor of this parameter class that I showed you before. So we'll pass in an array of attributes, check a couple of keys, and then move them into private properties. And in the end, we have a if not this name, throw annotation exception. Perfect. Now, when the mutation-based testing framework sees this, they will say, okay, let's change this to a if this name. So just going to remove the not. Meaning that the tests that expect the annotation to be thrown will figure out the annotation is not thrown. And your test expecting the annotation not to be thrown will get the annotation thrown, meaning this should be detected by your unit testing tool of choice. If not, then you probably should rework your test because it's not good enough to cover these minor changes. And that's basically the whole gist of it. So these mutants do have different states. So a mutant can be killed, which means it got detected correctly. A mutant can be escaped, which means that modification wasn't detected at all. A mutant can be uncovered, meaning there is no unit test so far for it. And obviously, they can also fatal error if you do some really fancy stuff with PHP that you probably shouldn't. And they can also time out if your unit testing tool of your choice just blows up for whatever reason. The mutation-based testing framework tool I want to introduce you to is called Infection PHP, which at this point is the only mutation-based framework testing tool for PHP 7. There used to be a tool called Humbug for PHP 5, but they never made the change or the switch from PHP 5 to PHP 7. So up to this point, it's just this is the only one that you can use. The interesting part of this is that Infection PHP works on the abstract syntax tree of PHP. So Humbug, the tool for PHP 5, had to completely parse the PHP code and then make decisions based on what keywords were found and the order and whatnot. Using the abstract syntax tree of PHP internally, it's a lot easier to figure out like where you are and do proper replacements. I just brought you this example that would replace plus versus minus. In this mutate method, you can see that we just return the minus node, leave the left and right node intact. And that's basically it. So that's extremely easy to implement if you want to come up with your own fancy logic. The infection PHP guys are very active in improving performance and stuff. So the first version of this talk I did last year, I think in September at the Symphony Live Berlin conference. And like a day or two before, they announced via Twitter that they brought up a new release that would take like 58% less of memory, which is really, really insane, just by switching to classes internally instead of their object-like array structures. So if you don't take anything away from this talk, don't use arrays, use proper classes. Great. So the cool thing about infection PHP, it comes with support for a bunch of testing frameworks. So you don't need to be committed to just one. It comes with support for PHP unit. It comes with support for PHP spec. And also for Codeception. So if you use any of those, you can use infection PHP out of the box. Basically because it doesn't hook into these frameworks, but just operates on their output log files, however you want to call it. So that makes it quite flexible. Great, so how does it work internally? First of all, it will run all the test suite to see if all the tests pass, because obviously if there is an error, it doesn't make sense to continue. It will then mutate the source code with a set of all the predefined mutators. We'll see at a later stage what that means. For each of these mutants that got created, only the tests run that cover the changed lines, so you don't run the whole test suite. Just the ones that affect the lines that have been changed. And then the results get collected for all the killed, escaped mutants, for the errors, and for the timeouts. And that's basically it. To install it, you can download it from GitHub. You just run it on the CLI. If you run it the first time, it will ask you a bunch of questions, like what are the source directories, where the files are located. Any directories that should be excluded for whatever reason. If it doesn't find the phpunit.xml file automatically, it will ask you where it is. You can define a timeout for the test suites. You can also store the text log file, which is quite helpful to figure out what is going on when something fails. The configuration file is just a simple JSON file that you can also then edit afterwards quite easily. Again, we'll cover that later, what you can do with that. So if you run it, if you call it on the command line, the output looks like this. So the top level part is actually the PHP unit output. Then you can see it will generate the different mutants that it identified, and then have a PHP unit-like output to figure out like what's going on. As you can see, the dot means it's a killed mutant, and M means it's escaped, S means uncovered, E is a fatal error, and T stands for timed out. And we'll also get a nice overview of what happened. Like 325 mutations were generated, out of which 255 were killed. One wasn't covered by a test, 60 were covered but not detected, and 9 errors were encountered. And then we'll see some metrics again. We'll cover that at a later point. The most important part to figure out like what is going on is the log file, infection log PHP, where you will see 3 sections mainly, one for the escape mutants, one for the timed out ones, and one for the not covered mutants. And this will give you clear insights of what is going on, what was run, and what you potentially have to change then to fix this. I have a few examples to give you an idea of how does that look like. So basically, this is one of the escape mutants. So we didn't detect it for whatever reason. So the original line read, if not is string ID or empty ID, then throw an exception. And Infection PHP changed that to a logical AND, which means that something does not need to be a string, but still is or has to be empty. And that was a case that was not covered by the unit tests. So questions to all of you: what is not a string but can be empty? Does anyone have an idea? It took me a while to figure that out, to be honest. No one. Null. Quite close. It's actually an array. So what I had to do is just add another test that would just pass in an array to this method, and then this mutant was catched and properly detected. So that was an easy fix. Great. So here's another one. That's also an escape mutant. So the original line was that the value parameter was turned to lowercase using string to lower, and then compared to the string true, which is also lowercase. Now, bloody infection PHP removed the string to lower, which obviously made the comparison fail. And thus the mutation was or is escaped. So we had to fix that as well. Quite easy. Not only passing in the lowercase, the uppercase values, but also passing the lowercase corresponding values, and we are good to go. I mean, this is kind of questionable. Just going back one slide. Does that really make sense to test that? But I mean, on the other hand, it could potentially happen to all of us that we just accidentally delete that line for whatever reason, and then problems can occur. So even though it might look a bit stupid, there is a reason to think about if you really need to cover this, or if you really want to cover that. This was also interesting. Another escape mutant. So we'll do a bit of magic using reflection API and stuff, and we're calling the set doc block method and just pass in some inherit doc string. And this wasn't covered by the unit test. So if this line was removed, nothing did change in the test. So infection PHP assumed this test is broken. Well, to be honest, in this case, I don't really care if the dot block is set. So this is really questionable if you really want to test for that. But depending on your use case, it definitely makes sense to have a test for this. So you need to be very, well, how should I call it? You need to be open to figure out, like, is it really needed? Is it really necessary to apply all this, or can you ignore different parts that infection PHP complains about? That was also a good one. So that was the one that was not covered by any of the tests. So we have a for each loop. We iterate over a couple of aliases, and there is an if empty construct below there, which by default has continue, and infection PHP changed that to a break. And obviously none of the tests did recognize that, because technically the alias can never be empty. So we do a check on top that will tell us if it's a type alias, and then just get the return type. Otherwise, we use the name. So by no means you could ever run into this if statement. So the fix was easy. We just removed it, and everything was fine. Let's just see in the chat there was a question. Does an annotation exist to ignore findings? Not an annotation, but you can use the configuration. I'll show you this later on, what you can do to ignore these things. Great. Now, having fixed all these problems, we are down to 324 mutations, out of which 257 sorry, were killed. 58 were now covered or not covered by tests. So the 2 were added to the killed ones that we fixed. Interestingly enough, the metrics are exactly the same, so 81% and 99%. So even small changes don't have that much side effect on the different metrics. Speaking of metrics, there is the mutation score indicator metric, which is like the primary or the most important metric that will just tell you how good your tests are. If there is too much of a difference compared to the code coverage, then you know your tests are not effective enough. So that's important to keep in mind. There's the mutation code coverage, the MCC, which also should be around the value of your code coverage. Right. Then we have the covered code mutation score indicator, which will tell you how good the code is that has tests. So it will ignore not tested code. So this can also then give you insights how effective your tests really are. And speaking of that, 81% MSI and 81% covered code MSI, that's not too bad, but not the best thing in the world. Let's put it that way. If you compare that to the code coverage that we had of about 99%, there is quite a bit of difference, meaning that the tests aren't really that effective as they should be. Yeah, exactly, Dave. So the CC MSI should be close to 100% ideally, depending how good your tests are. Speaking of performance, and that's probably the thing that really hindered the breakthrough of mutation-based testing in the last century. It's quite performance intensive. So if you run the regular unit tests for this test suite, they'll take less than a second. If you run infection PHP against the same code base, we are at 38 seconds by default. So you can see there is a huge difference. You can speed things up because infection PHP by default just runs on one thread. So if you add a -f threads parameter and set it to 4, we are down to 19 seconds. But still, it's a huge difference compared to just running unit tests. But obviously, there's a lot of stuff going on, creating all the different mutants, running the test cases, collecting the data, and so on and so forth. So you definitely have some overhead. You can improve this, and this is exactly then where the ignore question from before comes into play. You can define a lot of exceptions. So by default, infection PHP uses all its internal mutators. So that's what the at default true here means. You can change that and just say, okay, we are using the default set, but I'm not interested in any of the Boolean and any of the operator mutations. We'll just skip them completely for whatever reason. If you want to be a bit more picky about what's going on, you could also say something like this, where it simply says, don't run this logical not mutator for the proxy configuration generator class, or for any class in the proxy configuration property generator namespace. So we'll just ignore those completely. You could also limit this to method calls, saying don't run this logical not mutator for the proxy configuration generator generate method, but for all the other methods within that class. You could also say just don't use that mutator for any method generate in the proxy configuration namespace. So that's quite a lot you can do then to filter out or to limit stuff. If you really need the hammer to nail things down, you could also limit this to line numbers, saying just don't use this logical not mutator for the proxy configuration generator class in line 123. I would not recommend doing that, because obviously if you refactor the class quite often, you need to make sure that the line numbers are aligned in the configuration file. So I would really use that only if nothing else helps. Try to avoid it as much as you can. The pretty cool thing with the latest versions of Infection PHP is that they do validate this JSON configuration. So if you have a typo, like missing the E for ignore, it will tell you, saying there's a mismatch in the JSON configuration and the JSON schema. Just have a look and fix it. Before that, it just failed and you had no idea why. And now at least you get a decent error message. Another way to increase the performance is to make use of the PHP unit xdebug dump. So you can call PHP unit and let it output the xdebug dump. Pass it then again to create the code coverage information, and then point infection PHP to the already collected code coverage information. So that speeds things up quite a bit. As an alternative to that, you could also use the pconf extension. You don't need to use xdebug, which should be faster and consume less of RAM. So that's quite, or that can give it quite a boost. If you want to run it in CI, that's no problem. You can do that. If you do that, you can define a minimum MSI and a minimum covered MSI. So if the real values are below that, it will just error, and then your build will fail. So it more or less then looks like this, and then you can react on that. Also, speaking of CI, there's another neat little trick that you can use to speed things up a bit, and that is filtering just the changed files from the Git commit and passing the changed files as a filter to infection PHP. So it won't check like the whole code base, but just like the files that have been changed in the recent commit. So that should also then give you quite a bit of performance boost and deliver results faster than before. So there's a lot of stuff done there to make sure that this thing can run as fast as possible, and to make you not wait so long. That's probably the best way to put it. And that's basically what I have prepared for today. Thank you very much for listening. It was a pleasure speaking to you, even if I couldn't see you in person. Maybe we'll have another opportunity in the future at some point. And as the organizers already stated, I would really love to get some feedback for this talk. I've done it a couple of times now at a few conferences, at a few meetups. I'd like to improve. So if you have any ideas, what I could add or change, just let me know. Thank you very much.
Thank you very much for that. Right, so if anyone's got any questions, if you just pop them in the Q&A thing. I, as an organizer, can't actually add Q&A, questions. Oh, we've got one from Dan. Do you recommend running mutation testing on all your code, or can you run it against just the most suitable code for mutation testing?
I guess the proper answer is it depends. If you introduce mutation-based testing or infection PHP in particular to an existing code base, you will probably get a lot of errors. So that can be quite problematic. Using the part with a let me just go back. Using this one where I just run it against the changed files, that might be sufficient then. Yeah, because I guess you could, it could be quite distractive to get a lot of errors every time you run it. I'm not sure if you can filter out certain directories, probably. I'm not sure what would happen if infection PHP doesn't have the whole code base available for testing. So maybe you can change the source directory to one of your namespaces that you want to test. But I haven't tried it so far.
Cool, thank you. If you've got any follow-up on that, Dan, just pop it in the thing. Okay, so one from Jonathan Jeffries. So while you're writing unit tests, are you running the mutation tests as often as you're running the unit tests, or just before you commit, or just in CI?
So my current way of doing things is to run the unit tests on every commit, but to run infection PHP before pushing the code to origin or to wherever I want to push it, because yeah, depending on the code size or code base size, it can take quite a while. So it can be quite annoying if you would test it on every single commit. So that's what we are doing. And then obviously have it on the server side, yeah, running the whole build pipeline for every push then.
So on your CI, you are actually running it every single pushed commit, or just when you're trying to, just before you merge it into master or whatever your workflow is?
That more or less depends on how the different teams in our company have set things up. So some run it on every single commit, whilst others just have it for yeah, for the merge commits to master or whatever they call that branch.
And what's the false positive rate on these things? You know, when you look at them, do you think, you know, I can see why it's complaining, but it's not really a false positive? Are there some that are like genuine, like this really is a false positive?
Yeah, I mean, it kind of depends what you would consider a false positive. Well, let's go back to the overview. Let's see. Yeah. So I mean, the first time when I run this against the code base, I was quite convinced that I've done a quite good job writing the tests and stuff. And then you run this tool and you see all these escape mutants and you think, oh gosh, what's going on? And then yeah, you'll dive in and you really see a lot of valuable things, I would say, like stuff you probably haven't thought of. But obviously also then there was the one like in this case where I had to add the test for an array that was passed in. Technically, it doesn't make sense to pass in an array in this method. So that's kind of questionable if it's reasonable to check for that. So yeah, I think for every change, I guess you have to yeah, discuss with yourself if it's really necessary to do that or not, and then maybe exclude it from the checks if you're really annoyed by by
Mm.
the errors popping up.
And I don't want to monopolize the questions. If anyone else has got questions, do pop them in. But this will be, I promise, my final question for now. So tools like PHP Stan and SARM have got quite good caching now. Certainly the latest PHP PHP Stan from like version 12.
Right.
Is there a similar kind, like I'm just imagining you could cache the AST and then look at the files that change, and then go, okay, right, they've only got to go and modify these files just to try and really, like, more on your when you're doing the local development. It's like, okay, I'll run it again. It's just focusing in on what's changed, because presumably you can look at a test and see, you run a test so you know exactly what production code, what software under test has been executed, and it's just in there those changes that you need to update. Is there something along those lines that could be done?
I didn't follow the latest development, to be honest. Could be. I'm not sure if it would be really faster than parsing the AST all the time. Like, I mean, you need to read the cache file anyway, so I don't know much about the PHP internal stuff to be to be able to tell you what's quicker. But at least that sounds like a reasonable idea. Or maybe I should open a GitHub issue and see what will happen.
I suspect it's a non-trivial.
Yeah,
to
probably.
I mean, is it performance is the biggest blocker for people using this, or is it just people see too many what they would think false positives?
Well, I guess both. I mean, if you have really large code base, this probably can run for hours in the worst case, and then also then come back with tons of errors, which makes it then really hard to figure out like what to fix. I mean, it's kind of similar, I guess, with adding type hints and stuff, where the first time you did it, you run into hundreds of errors, and then you figure out, well, is it really worth fixing everything? Or you wonder, like, how could this code ever run properly? Yeah, I mean, I guess that's always a problem when you add tools like that late into a project or to a legacy project, however you want to call it. If you start the development from scratch and add these tools, I think it's much easier to get used to it and cope with the potential problems that come along.
Yeah, I can imagine if you do this from the start, you just have very few issues. Well, thank you very much for that talk. I don't know if anyone else has any more questions, but if you do, and I don't know, Stephanie, don't mind joining us after the final talk, we can all chat away then. So if anyone does have any questions about this, join us in the chat afterwards, or I'm sure you're open to discussions on these things on
or
Twitter and stuff.
Ping me on Twitter or via email or whatnot. So.
Fantastic. Brilliant. Thank you very much.